Ibrahim, I said last day, this is probably going to be among the toughest stuff I'm going to teach you. This is not meant to scare you. This is meant to say to you, if you find this tough, you're normal. Okay? Don't be going, oh, I found this tough, I'm stupid. No, this is a tough concept. Sierra, stick with where we are, because I think with where we are, don't fall behind trying to catch up, because a lot of what we did last day, I'm going to be repeating today anyhow. Okay? So just get it later. What did we say? I'm going to do a real quick review. Don't try and write all this down. We said that we can look at how chemicals bond. We can predict how many of each you need by looking at the valence shell. In particular, Martin, by looking at the valence charge, the ionic charge. I gave you this notion of hook diagrams. We started doing it intuitively. And then, Alyssa, I said if you wanted kind of a little handy-dandy shortcut, we could use what we called the crisscross rule. If you wrote the element and its ionic charge, and you wrote the nonmetal and its ionic charge, the 3 ends up below the Mg, that's the subscript, and the 2 ends up below the P, that's the subscript. And then we also learned the Ide rule. What was the Ide rule when you name something? Yeah, Hannah. The nonmetal will always end in Ide. So instead of oxygen, we'll call it oxide. Instead of phosphorus, we'll call it phosphide. Instead of chlorine, we'll call it chloride. And this explains something you might have wondered. Instead of fluorine, when it's combined in your toothpaste, we call it fluoride. That's why it's called fluoride and not fluorine in your tooth. Fluorine would be very bad to have in your mouth, because if it dissolves glass, it wouldn't be good for you. Fluoride is stable, and it helps actually strengthen the enamel in your teeth. We got right to here. Yes? Yeah. Remember, I said the location of the numbers is very important. The subscript, the lower number, that tells you, you know what, let's go black, Mr. Dewitt, because blue on blue probably, you know what, let's go bright red. The number of atoms. The superscript, the upper number, the number that's in the upper right, that's the ion charge. Trevor, if in the wrong place, they're wrong. I'm not going to give you part marks. In other words, if you say to me, if I said, tell me the chemical formula for magnesium fluoride, oh heck, magnesium sulfide, and you said, oh, it's Mg2S3. No, that's not the chemical formula for magnesium sulfide. 2 is the ion charge for magnesium, technically 2 plus. 3 negative is the ion charge, and Sierra and Ibrahim and here's what we did last day. We said if you wanted to write the formula, it's going to end up being Mg3S2, and don't put pluses or minuses down there, please. Okay. What would the chemical formula be for calcium chloride? What would the chemical formula be for calcium chloride? Drew? Yep. Try the next 3 on your own. I'll do them up here, and then if you can look up when you're done and see if you got. I left you 3 to do there, yeah? Yo. Pardon me? No, that's telling you how many, but it's not. It's just a trick. It's not actually good science, but it does work. Just don't put pluses or minuses, but it turns out that'll tell you how many of each you need. This is where the crisscross short. So I got Al2O3, aluminum oxide is how you'd pronounce it. NaF, or what would I call that? Sodium fluoride. Now, here is the little thing you have to remember, Mandy, with the crisscross rule. If I combine calcium and oxygen, what's the charge on calcium? How many extra electrons does calcium have? 2. What's the charge on oxygen? 2 minus. How many electrons does oxygen need? 2. You know what? You only need one of each. But if you do the crisscross, you're going to get Ca2O2, which is wrong. So what it really should be is crisscross, then reduce. Is there a 2? Is there a 2? I can reduce that. You know what? I'll use a fraction term, even though that's not a fraction. I'll say you can reduce it to lowest terms. It's really 1 and 1. Wait a minute. Am I going to bother, Kevin, putting the 1s? Say no. So I wrote here, the answer is not Ca2O2, it's CaO, calcium oxide. You have to reduce the subscripts to the lowest terms. That's why this is a good trick, but you have to be careful, because if you're not paying attention, you can make a mistake. So I wrote here, do number 5 and number 6 on the worksheet. I think I gave you this chart. Yes? I did. So we're going to do the first one together, and then I'm going to give you about 10 minutes, maybe less, to finish this. So we're going to combine phosphorus and strontium. First question is, we have to identify which one is the metal. Which one is the metal? Oh, by the way, you're going to want your pink periodic table out. Oh, yeah, and you're going to want to turn the page. Which one is the metal, phosphorus or strontium? Phosphorus is the metal? Which one is the metal? Which one is the positive? The metal, the positive. Which one? I don't want to write strontium. What's its abbreviation? Is it ST or SR? SR? Okay. So I'm going to go like this. SR. And you know what? I'm going to put its ion charge here. What's the ion charge for strontium? Phosphorus is the nonmetal. That one I've already memorized by now is P. What's its ion charge? 3 negative. What's the formula going to be? SR, 3 of them. P, 2 of them. What am I going to call this? Strontium what? Ide. That's the ide rule. And then this last question I haven't asked you yet, but we're going to start to ask this more and more often. To make 1 molecule of strontium phosphide, what's the total number of atoms you actually need? Can you see it? 5. Don't times 5. 3 S's, right? And 2 P's. Total, Brian, of 5. Is that okay? So, take a couple of seconds, try doing this. Then we're going to get to the, this is 5 and 6. Is that what I have on your worksheet? Finish this chart. You have this chart, yeah? Fill it in. I'm going to freeze the screen, and let's see if we end up with the same thing. You can check with your neighbor if you want to as well. Number 5 says, try these ones. If we use the crisscross rule in number 5, I think you're going to get CaCl2. Yep. I think you're going to get Al2O3. Mm-hmm. Oh, we did these ones already, didn't we? Yeah. Okay, sorry. Then I thought I'd given you number 5. So number 6, I got this when I did mine here. So first one I got, I figure if you get the formula, the name, and the atoms right, you got the rest right. So I got SR3P2, strontium phosphide 5. We did that one together. Is that on the other? This is number 6, I think, yeah? Yeah, I don't have, oh, so you guys need the sodium nitrogen. Okay, The sodium nitrogen one, sodium is the metal, Na plus, right? N3 negative. So it's going to be Na3N. Is that right? I'm doing number 6, the third one. You know what, Mr. Dewick? Why don't you just show them the handout since you have it here? Looks like for some reason I didn't copy all the questions. Don't ask me why, but I didn't. So here, it's going to be Na. It's going to be N3 negative, so it's going to be Na3N, and you would call that sodium nitride? Yes? And 4 of those. Chlorine and magnesium, Mg is, that's a good question, 2 plus. Cl is 1 minus, so it's going to be MgCl2. Magnesium chloride, and that has 3 atoms in it. Calcium and sulfur. Calcium is 2 plus, oh, that works out nice. Calcium is 2 plus. Sulfur is 2 minus. You know what? When the numbers match, I don't even bother crisscrossing. I just know you need, Grace, 1 of each. I know you'd get a 2 and a 2 and you could reduce, but I just know it's going to be CaS, calcium sulfide. 2. Then for you guys, it's turn the page. For me, these are the ones that I did that I had in my handout. So this is why you guys were confused when I started with phosphorus and strontium. Now I figured it out. So we did strontium phosphide together.
All right,
I got AlBr3, aluminum bromide, 4 atoms. I got Ag3N, silver nitride, 4 atoms. I got zinc, ZnI2, zinc iodide, 3 atoms. Al2O3, aluminum oxide, 5 atoms. LiCl, lithium chloride, 2 atoms. Is that right? Okay. I apologize. This is where it's going to get tough. Because now, up until now, Jolene, I've been staying out on the edge of the periodic table, and I've been carefully picking nice elements. We're going to now move to the middle of the periodic table, where all of a sudden you notice elements have more than 1 ion charge. We have a fancy word for that. We call it multivalent. Did I hit record? I did, good. So, if I said to you, name these compounds, copper chloride and copper chloride, but are they the same formula? We got a problem here. You see, it turns out copper and many, many other metals can form. So where it says name these compounds, just leave it blank. We're going to come back to it. Some atoms, metals and metalloids only, can form more than 1 ion charge. Oh, our physics lesson's now uploading. Let's come back. We use a Roman numeral to show what charge the metal ion has. This is done only when a metal can form more than 1 type of ion. Which metals can form more than 1 type of ion? All of the ones on your periodic table that have more than 1 plus. So copper, as an example. Find copper. The most common ion that copper forms is the first one. What's the first type of ion it'll form? A 2 plus. But it can also be stable and form a 1 plus. So you ready? Now we're going to go back and name these compounds. What's the charge on chlorine? What's the charge on copper? I don't know. I'm just going to put a box there temporarily. But in my formula, how many coppers and how many chlorines did I need? One of each? So what do you think the charge must have been here so that when I did my crisscross, I got 1 and 1? We would call this copper Roman numeral 1 chloride. And you would read it as copper 1 chloride. Mr. Dick, I don't really know my Roman numerals very good. Did I put, oh, no, I didn't put them on the back. You're not going to get much more than a 3 or a 4 anyways. Compare that with this next one. So I know chlorine is minus. What charge is copper there? Well, chlorine ended up with a 2. So what must have been the charge on this copper ion? This is going to be copper 2 chloride. Now, as soon as I do this, Jaden, kids go Roman numeral loopy. They start putting them everywhere. You're only going to put them on metals that have more than one valence charge, more than one way to form an ion. The fancy word is they're multivalent. In other words, everything in column 1, we never need to put Roman numerals on. Everything in column 2, and now you're starting to clue in why I've been picking the same elements over and over and over. I haven't been picking some of the funkier, cool ones. So for example, element 45, rhodium, if I write that as a name, there's going to be a Roman numeral in it. But element number 21, scandium, only has one valence charge, Matt, no Roman numeral. So let's kick it up a notch. It says, fill in the following table. Continued on the next page. I've told you the chemical name is iron 2 bromine. Okay. What's the symbol for iron? Let's put a little Fe right there. What's the symbol for bromine? Br. What's the ion charge on bromine? Negative. What's the ion charge on iron? Depends, doesn't it? Looks like iron can have a 3+ or a 2. No, wait. I told you which charge to use. Which charge do I want you to use? Put a little 2+ there. And now we crisscross and we can get the formula. Fe, how many? Br, how many? Fe, how many Fe's? How many irons? 1. And how many Brs? 2. How would I pronounce this? I would call this iron 3 bromide. That's how I would read that. Sorry, iron 2 bromide. And you know what I would actually do? I would write a Roman numeral like that. I would write iron 2 bromide, and I would just say the 2. By the way, how many atoms are there in this compound? Grand total. 3. Now, if you're saying this got tougher, yeah, it did. This is much tougher. So you ready? Now let's do, I was looking at the next one, iron 3 bromine. So this time, what charge do they want me to use for iron? 3+. And bromine has 1-. Now, when I use the crisscross rule, the chemical formula is going to be Fe, Br, how many Fe's? How many Brs? How many Fe's? How many irons? 1. Am I going to put a 1 down there? It's just going to stay invisible. How many bromides? 3. By the way, how many atoms does this one have now? 4. And I would call this iron, 3 bromide. iron 3 bromide. I said do number 7 on the worksheet. It continues on page 4. So see if you can, we did the first 2 already on my chart, but then you have copper 1 nitrogen. You know what? Let's do 2 more. Let's do these 2 together, and then I'll let you do the 4 on the back on your own. So copper 1 nitrogen. Copper is, what is copper? Cu? It's multivalent. Oh, wait a minute. Which charge do they want me to use? 1. Nitrogen is 3 minus. What's the formula going to be? Cu3 and, oh, 1. Am I going to bother writing the 1? No. What would I call this? Copper 1 nitride. How many atoms does this one have? Each molecule has 4 atoms. Gold is multivalent, which is why I've avoided it so far. Gold. Au! Oh, yeah. That's how I remember it. Oh, they want me to use a 3. You know what, Mr. Dewick? Let's change colors first of all. Gold, Au. They want me to use a 3+. Now, the nice thing is the non-metals, Danielle, none of those are multivalent. So we use the non-metal as kind of our reference point. It's going to be -1. Hey, when I crisscross, what am I going to get here? Al, how many? 1? Or Au, not Al. Au. Good gosh, I'm doing aluminum. We're doing gold. Au, 1. Cl, 3. We would call this gold 3 chloride. And it looks like this one has 4. So I got 4 more for you to try. I'm going to pause. I'll freeze the screen. You guys can try these 4 on your own. Is that right, what I got? Yeah. I got PB3P4, lead 4 phosphide, 7 atoms. I got PBS, lead 2 sulfide, only needed 2 atoms, because here when I crisscrossed I was able to reduce. I got NiBr3, nickel 3 bromide 4, and then this one was tricky because I was going to say Cr2O6. Nope, that'll reduce. Divide by 2, divide by 2. So I ended up with Cr1. Did I write the 1? No. O3, chromium 6 oxide, 4 atoms. Yeah.
What is 5 in the Roman numeral?
V. Yeah. Okay. By the way, why Roman numerals? I have no idea. It's the way it's done. Josh, if I could, I would change that because I would say, why wouldn't we just use the regular numbers? Like, why wouldn't it be chromium and a number 6 oxide? I'd figure it out because I'm not in charge. I think the naming systems are kind of stupid, but they are what they are. It gets tougher. Sorry. Going from the English name to the formula isn't so bad if they tell you the ion charge. Well, you'll see what I mean in a second. So, multivalent metals. Each of these compounds contain a multivalent metal ion. So the name is going to have a Roman numeral. The name is going to have a Roman numeral. The problem is figuring out what that Roman numeral is. Going from a formula to a name. This is the single toughest thing I'll teach you in a long time. How do you do it? First, we're going to start by looking at the nonmetal, because that doesn't change. The charge on this will never change. And remember, the charge on the metal must balance it. Say, what? Show you what I mean. CR. What is CR? Chromium. Go look at it on your periodic table. What element number is it? 24. Sit up, Josh. Thank you. You can do it. What element number is it? 24. Is it multivalent? Is there more than one ion charge? No! Oh! Okay. I know there's going to be Roman numerals in my formula, in my name. Here's the question. Which Roman numeral? Now, I'm going to start off going very systematic. Some of you may reach the point, Christian, where you kind of can see these and do these in your head, but I found kids have struggled with this in the past, so if it seems like I'm going slow, that's a good thing. That means you're getting the hang of it. You ready? You ignore the chromium. You look at the bromide. What's the ion charge on one bromide? How many bromides are there? 2. So I'm going to argue that there is a total of... Is that okay? You know what that means? There has to be, otherwise it won't balance. How many chromiums are there in the formula? 1, 2, 3, 4, 5, 6. Is there a subscript at all? Is there, what number is sitting right there? 1. So that one chromium must have used that charge. It's going to get tougher when these numbers change. But we could say this then. What must the charge on the chromium be? It must have been 2 plus because it had to cancel out 2 minuses. So we're going to write, you know what, Mr. Dewick? Stay in the same color. Chromium. What's the charge on this chromium ion? So what Roman numeral will I go with? And then I'm not going to write bromine. What will I write? You okay, Josh? You going to make it? You look a little tired. So, let's look at the next one, which is also, by the way, a chromium and a bromide. Except, how many bromides are there this time? So what's the total negative charge in this ion? Sorry, in this molecule. So what must the total positive charge be? How many chromiums are taking care of that? Only 1, so it must be chromium 3 bromide. Is that okay, Tensei? I know this is tricky. You with me? All right. Nickel, Ni. Go find it on your periodic table. Is it multivalent? Yeah. See, by the way, you always want to check if it's multivalent first, because if it's not, it's nickel sulfide done. Which, Jaden, I would argue, is way easier. So always check for multivalence first. In other words, you're going to have to get in the habit of looking up the metal all the time on your periodic table. If I was clever at it, I would have given you a periodic table on pink. Okay. Look at the sulfur. What's the ion charge on one sulfur?
2 minus.
How many sulfurs are there in this molecule? So what's the total amount of negatives here? 3 negative 2s, right? So what must the total positive charge be? Has to be that. Now, how many nickels are there in this atom?
1.
In this I said atom, in this molecule. How many nickels are there in this molecule? Not 1. 2. What do they totally have to be? 6 plus? What must each one be then? Do you see how many mental gymnastics we have to go through? And I haven't found a way to make it simple. I can make it systematic, like we just did, Trevor, but I haven't found a way to make it. So it's going to be nickel. What must the ion charge on nickel have been? 3. And then sulfide. Oh. Oh. Wow. Do you guys think you can try this chart?
Yeah.
You know what? Let's do one more. Well, let me see. How much do I have here? Okay. You know what I'll say? If you want to just work ahead on your own quietly and look up, you can. I'll continue to go through this with the class. So if you think you've wrapped your brain around this, go at your own pace. Just look up to make sure that you've done the previous ones right. Danielle, you ready? Fe. Go find it. Multivalent? Die! Okay, that's okay, that's okay. Ignore, because I don't know which multivalent to pick, but I can reason it out by looking at the nonmetal. Iodine. What's the charge on one iodine? How many iodines are there in this question? So the total negative charge is... So what must the total positive charge be? How many irons are there in this molecule? In other words, what number is sitting right there? In this case, it's invisible. So, you know what? One iron must be 2+. The charge on iron has to be 2+ to cancel it out. This is going to be iron 2 iodide. Oh, are we filling in number of atoms? No, we're not. Never mind. So this will work. Okay. I'm going to skip the next. Let's go to the Hg3N2 because that looks ugly. See it down the way there? Okay. Hg. What's that? Mercury, element number what? 80. Find it. Is it multivalent? See, again, if it wasn't multivalent, I would smile and I would say, oh, the answer is mercury nitride, idiot, right? But, it's multivalent. I have to now deduce or figure out what valence charge it used. And I figure that out by looking at the nonmetal. What's the nonmetal here, Danielle? What's one nitrogen? What's its charge? How many nitrogens are there in this particular molecule? So the total amount of negatives is, which means the total amount of positives has to be that, right? Except, how many mercuries are there in this molecule? 3. So what must each mercury be so that I can get a total of 6+? That's how it's done. This is going to be mercury 2, and then it's going to be nitride. I wish I could find a way to make this simpler. I haven't. I've been trying to figure this out this is my 3rd year teaching this. I've gotten more systematic, and I think if you practice it, it'll kind of become a little more intuitive. Maybe like a circuit in your brain will kind of set up. So I'm going to do the next ones quietly. You can try them on your own. Was that okay, Danielle? I'm going to let you try the rest, and I'll do them up here. I'm going to pause the video. I won't freeze the screen, though. If you get stuck, you can look up. So, very quickly, I said, okay, it's got to be iron 3 chloride for the second one here, lead 2 fluoride, lead 4 chloride, mercury is always tough, mercury 3 nitride, mercury 2 iodide, copper 2 oxide, and mercury 3 oxide. Is that right, or did I make a mistake at all?
That's what I did. That's right.
So you got? Okay. We're going to press pause in just a second. Stay with me for, I know I've been talking a lot. On Tuesday, we're then going to say, okay, how are we going to do the polyatomic ions? That's going to be Tuesday. So what I'm going to do right now is I'm going to give you part 1 of the homework, and you'll have about 15 minutes. You can probably get it done in class. So right now I'm going to say pause here.
No. No, I didn't. Not today.
If you take a look at this, you can't do all of it yet. Okay? So this is called section 3.2 homework. You are capable of doing the entire front page. The back page is where the polyatomic ions start. As usual, I have attached the answers, but here's what I would suggest. Tensei, you with me? I want you to be paying attention. That's what I'm saying. Focus here. Put that away. Just hang on. I would encourage you, try doing like the entire half page and then go check your answers. And then try doing this half page and then go check your answers. See if you can get this right. Someone said, is this due tomorrow? Because I'm going to be assigning the back page tomorrow when we finish off the lesson. This isn't due tomorrow, but it's going to be, if you don't want homework for the long weekend, then you probably want to get it done as much as you can today, or plan on really hustling tomorrow. If you have the ionic and covalent bonds sheet done, if you want to hand that in today, you can. Otherwise, as far as I'm concerned, this one is due tomorrow. Okay, you got the remainder of class.